Hello everybody, this is Jim Corkins, and we are continuing on with vectors, the vector component. And so this is 2.1, and we're going to do a trigonometry review. So, again, if you haven't read those chapters in your textbook, please do so. They're indicated in Canvas. Now, trigonometry review. So, there's some things you need to know, and I think you have heard when you've done pre-calc or your trigonometry courses, you've heard SOHCAHTOA. Okay, so SOHCAHTOA is sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent. Now, again, the Pythagorean's theorem is going to be something that you need to know. If you need to take the inverse of to find theta using sine, theta is going to be equal to the inverse sine of opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent of theta, theta using tangent, is the inverse tangent of opposite over adjacent. And let me rewrite this so it's close to the Pythagorean theorem, because that's going to be important. Now, if theta is right here, if theta, and in this diagram, you have a acute hypotenuse, theta is right here, and that is going to be, and the side opposite here is this side right here. That is the side opposite of this theta. Okay? Adjacent is always physically touching theta. So if your theta is right here, adjacent is physically touching theta. So some of us sometimes can forget what is opposite over adjacent, what is adjacent, opposite of what, adjacent to what. Typically, theta is taken right here, okay, in this side, from what you've learned from your trigonometry class, okay. And just remember, if you want to figure out what adjacent is, which will help you to figure out what opposite is, adjacent is the side always physically touching theta. That means the side opposite it is right here. Now, let's call this, just a review. Oh, again, c squared equals a squared plus b squared. But regular to this, if this is the side h, so which is going to be c squared, that's going to be equal to the adjacent side squared plus the opposite side squared. Okay? If theta is right here, so let's rewrite this. If we'll call this phi, which is an O with a line through it. Okay? If phi is right here, if you chose this as your angle, well, this will be the opposite side, and this will be the adjacent side. Okay? It's still the hypotenuse. So in this case, so phi, okay, so the sine of phi is going to be equal to, again, it'll be AC over BC. So sine is always opposite over hypotenuse. Okay, so AC is now the opposite side, and BC is now the adjacent side. Okay, and the hypotenuse is A to B, right? So A to B. So it depends on, I suppose what I'm saying is opposite and adjacent are relative to where you're choosing your angle. If theta is right here, over hypotenuse, so If theta is right here, then the opposite side and adjacent side are right here. But if phi is right here, so if your angle is right here you're choosing, then this is now opposite and this is adjacent. Okay? So that's a real quick review. But let's get into the practice of trigonometry. And we've got two really cool trigonometry review pages that are really important. I do think they're very special. Okay? So, here we go. We have three vectors, and we need to find out the x direction components of those vectors and the y components of those vectors. Okay? And so we need to find the sum of x and sum of y. All right? Now, C is pointing down and to the right, and here's the angle 40 degrees, and that angle is relative to the vertical. 60 degrees is with B, and that is relative to the horizontal. And A is already aligned to our system. So what helps me is establishing a coordinate system on these guys. Okay, so here's our coordinate system. And if you draw a coordinate system, make sure you label it. In our class, we're going to choose to the right is positive and up is positive. To the left is negative, x direction, and y is going to be pointing straight down. Negative y is pointing straight down. Okay? Now, what I'm going to do is I'm going to use blue as C. I'm going to use red as B, and A is going to just be black. Okay? So here's what you're going to do. And I'm doing this just to keep organized. I'm going to put my A vector x direction components here, and the A vector y components here. The B vector is right here. I'm going to put its components of x and y direction here. And then finally, C, I'm going to put those components right here. Okay? Now, I'm going to move this over a squidge. Here we go. All right. Here's what we're supposed to do. Here is our A vector. It is just pointing to the left. Okay? So, if you could see this, A only has x direction components, and it's pointing in the negative x direction. So the x direction is negative ax. We're going to be using variables to do this tutorial. A does not have any y component vectors, so we're just going to put a 0 right there. Okay? Now, some of them, if they're diagonals, you have to break them into up and down and left and right using the angle that's indicated, and you have to use the angle that's indicated. Okay? So the B vector here, this B vector's x direction component is right here. This B vector is pointing up and to the left. So starting from the dot, you got to go to the left and up. And so how I think about this is this and this. We're going to add these two vectors together. The resultant vector is, if you describe the hypotenuse as up and to the left, we're going to make a little triangle starting from the hypotenuse straight down and over to the dot, and encapsulating that angle 60 degrees. Now, if you need to draw those vector heads, well, this is pointing up and to the left. So the horizontal component is to the left. The vertical component is up. So B is pointing to the left. So the x direction is a negative B, because that vector is to the left. And this side is physically touching this. So this is going to be B cosine of 60 degrees. how I found that is this. Oops. If you take sine of theta, that is going to be equal to opposite over the hypotenuse, which is b. So to find theta, take the inverse sine of both sides. Actually, hold it. No, I'm so sorry. To find opposite, you have to multiply both sides by b. So that means opposite is equal to b sine of theta. Okay. Cosine of theta is equal to the adjacent side over hypotenuse. In this case, b is the hypotenuse. Well, to find the adjacent side, that's going to be equal to to find the adjacent side, we're going to have to multiply both sides by b. So b cosine of theta is equal to the adjacent side. This is the adjacent side. Which is pointing to the left. So that adjacent side is pointing to the left. And it's negative. And we said the adjacent side is b cosine of theta. So this is negative b cosine theta. So that's pointing to the left. And that's negative b cosine of theta. Let's make that b a little bit more interpretable. All right. The opposite side, well, this is the side opposite of theta. So our opposite side is pointing up, so that's positive. That vector is pointing up is positive, and that is going to be b sine of theta. So the y direction is pointing up, and this is the component, and I should put 60 degrees instead of theta in here. Let's fix that. So this is 60 degrees, and this is 60 degrees. We already have it here, so this is 60 degrees, which is the opposite side. Okay. Now for C, this is pointing, so here is our triangle. We want to draw our triangle. I mean, you could just say here's a rectangle, but which one of these triangles encapsulates the 40 degrees? Well, this bottom left one. So we don't want that as our triangle. We want this one. Okay? Now, this hypotenuse is pointing down and to the left, so the vertical portion has to be down. The horizontal portion has to down and to the right. The vertical portion is down. The horizontal portion is to the right. So which side here is adjacent to the 40 degrees? So which side is adjacent, which side is opposite? Well, this side is physically touching the 40 degrees. So that is adjacent. Okay? Now, adjacent is going to mean hypotenuse cosine of 40 degrees, which is pointing down. The opposite side of 40 degrees is pointing to the right, so that's positive. And so if this is C cosine of 40 degrees, this has to be C sine of 40 degrees. You can't have two cosines to a triangle. That would be crazy. So the horizontal portion of C, which goes here, is pointing to the right. So it's positive C sine of 40 degrees. The vertical portion is pointing down, is negative C cosine of 40 degrees. Now, I bet some of us believe that cosine always is the x direction. It is not. It depends on what angle you have chosen. In this case, right here, the angle we have chosen here, so the horizontal portion in this case is sine. This angle is pointed right here, which is touching the x direction, so in that case it is cosine. It just depends on which one you've chosen. Now the second page of our tutorial looks like this. You have a dot and you're supposed to write out these vectors that are indicated right here. Okay? So to do that, what we're going to do is, again, we're going to lay down our coordinate system. I try to use a dotted line, that way a solid vector shows up a little bit better. So positive x is to the right, negative x is to the left, negative y is down, positive y is up. Okay, so here's what we're going to do. And I'm probably going to need some room. There's a lot of ways to do this. Negative y. Okay, there's a lot of ways to do this, but again, I'm going to choose black as my black ink as A. Shows up better. B, I'm going to use as red. And C, I'm going to use as blue. Now, if you look in the x direction for A sine of 35 degrees is a vector in the x direction. And so this is actually a positive A vector, since it doesn't have a negative in front. So this is a positive A vector in the x direction. The y direction vector is also a positive A, but it's cosine of 35 degrees. The B vector is negative b cosine 75 degrees, and the y vector is negative b sine of 75 degrees. In the x direction, it looks like there is no x direction component of c. It looks like we do have a y direction component of c, which is negative c. So here's what I'm going to do. There's a lot of ways to do this, but I want to do it methodically in the best way that's going to teach you the point of this, which is to review your trigonometry. All right. Here it says the A vector. So I do one vector at a time. So in the x direction, we have A sine of 35 degrees. The important point here is the positive. Okay. The rest of this is just the name of this. So starting from the dot, and I'm going to start in order of x, A sine of 35 degrees is, so that's whatever that vector is, A sine of 35 degrees is pointed to the right. So I'm going to draw a rightward vector, and I'm going to call this A sine of 35 degrees. Which is positive. Now, the y direction component is also positive, which means it's pointing up. So whatever vector you drew first, you're going to add the second vector to it. So since I chose the x direction in this case first, I drew that vector first. Now I'm going to take the y direction component and add it to it. So the y direction component, I'm going to say, is this long, and I've added it to it, and so this is positive A cosine of 35 degrees. Okay? That means A starts from here, it ends here, so this vector is A. Now, we need to choose the angle. And so, let's choose an angle, and let's use a different color. Purple. So the angle 35 degrees. Where is that angle 35 degrees? Well, it can't be this side, because that's 90 degrees. So our choice is the bottom left side or the top right side. So what I recommend doing is So to figure out which one is 35 degrees, look for the side that is physically touching 35 degrees. Now I'm going to get rid of these guys right here. Oops, got a little bit of the hypotenuse there. If you look for the side that is physically touching cosine, so the cosine side always touches the actual angle, 35 degrees. So if I choose this as my 35 degrees, then this side is going to be the opposite side, which is sine, which works. Incidentally, we could have done this a different way, and I'll draw it over here. If you had, well, actually, I'll demonstrate it with B, okay? But that's one version. The other, so 35 degrees could also have been this side right here. And I'll show you how that happens. Because if we drew theta, if we started with the y direction part, this side would have been our beginning part, which would be a cosine, 35 degrees. And then this would be the horizontal, would be a sine of 35 degrees. So in this part, 35 degrees is the angle, which could be either this side or this side. Okay. Well, cosine is physically touching the angle 35 degrees. So this side over here cannot be it. So this can be 35 degrees as well. My point is, if we started here with this vector like we've chosen right here, this could also be 35 degrees. Okay? All right. Let's try B. And then in this case, let's start with the vertical portion. And so that B vector, the vertical portion, is negative B sine of 75 degrees. So we know that B vector is negative, so it's got to be pointed down. So I'm going to call that portion negative B sine of 75 degrees. Don't need the degree there, we already know that. Okay. Now, the horizontal portion, so negative in front, we labeled it negative, and then B sine of 75 degrees. Now, the horizontal portion is negative also, so that's got to be pointed to the left, so we're going to add that to it right here. And that's going to be negative B cosine of 75 degrees. Okay? Now, the resultant vector starts here. You started here, you walked down, you walked to the left, you ended right here. So the resultant vector goes from start to finish. So this is the B vector. Now we need to choose an angle. Our choice, again, can't be this side because that's 90 degrees. It's either going to be this side or this side. For me, I look for cosine, because that is always the side that is physically touching the angle. So in this case, the horizontal is cosine. Okay, so that means the other side right here, which is the vertical side, can't be physically touching it. So this has to be 75 degrees. And just like over here, this could also be 75 degrees. All right, so it could be one of those two. It depends on where you started out at. Again, if you started out with the horizontal portion, you would be pointing to the left and down. And the horizontal portion we call cosine, so that would be the 75 degrees. Finally, C, which is pointing, has no horizontal components, but it does have a vertical component, so C is going to be pointing straight down. And I'm going to put negative C right there. And that is our that is our tutorials, okay? And so completing these 2 pages on the tutorial is a really good review of your trigonometry. In these 2 pages, if you could do those 2 pages as indicated, you are as good at trigonometry or better than I am, okay? And so I hope you enjoyed this trigonometry review. Have a good day.